Alright, so this first problem here is just to remember how to use synthetic division because it's been a while. So when you're dividing by x plus 2, remember that means that you're going to put a negative 2 in the box. This is out of order, so it needs to be in order. So 2x to the 4th, 3x squared would be next. Notice there's an x to the 3rd missing, then minus x, and then minus 2. So since that x to the 3rd is missing, I have to put a 0 here for it. So I'm going to put a 2, a 0, a 3, a negative 1, and a negative 2. Alright, so let's do it. So put the 2 down, bring the 2 down. 2 times negative 2 is negative 4. You add this column, so it makes negative 4. Then you do it over again. This makes positive 8. I add this up to 11. 11 times negative 2 is negative 22. This makes negative 23 when I add. Multiplies to 46. Yep, and adds up to 44. Okay, so circle that number right there. That's my remainder. So when I'm dividing this expression by an x, what I've done is I've knocked down these x's by one level each. So the highest power was x to the 4th, so now this is x to the 3rd, x squared, and then x, and then nothing, and my remainder. So the way to officially write your answer is this: 2x to the 3rd minus 4x squared plus 11x minus 23, and the remainder, you just put plus and put that number over what you were dividing by. And that's how you officially write your answer. Okay, alright, so on example 2, we're going to do the same thing. Now, usually we're interested in getting a remainder of 0, and so we did not get that. This was just to review. So let's do this one. So I put a 3 in the box because this is my factor and I want my 0 up here. I got 1, negative 3, negative 4, and 12. Okay, so 1 times 3 is 3, 0, 0 here, negative 4, negative 12, and 0. So when you get a remainder of 0, then that's great. That's what you really want. So let's put our x's in there. x3, that means this is x2, and that's x, and that's nothing. So the answer to this is x squared minus 4. So I want you to realize something about that. So I've asked you to divide, so great, you've done that. But what we now know is that since it came out nice and clean, I know that x minus 3 times x squared minus 4 makes that problem. So another fact that I know is that this original problem is just these two things multiplied. So in a way, synthetic division helped me factor. When my remainder is 0, it basically factored for me. It pulled out the x minus 3 and then left me what was left over. So now, when I look at that, I have x minus 3 and x squared minus 4. Luckily, I can factor that into x plus 2 and x minus 2. So when it gets it down to a quadratic for me, it helps me because I know how to factor quadratics or solve them in many different ways. All right, I'm not going to talk about this there. So example 3, use the fact that x plus 5 is a factor in this problem to find all the factors. So when something's a factor, that means it's going to do like the last one. It's going to come out with a remainder 0. So remember, I put negative 5. Got 2, 11, 2, and negative 15. So bring my 2 down. Get negative 10. 1 times negative 5 is negative 5. Get negative 3. And finally 15. I get 0. So what I have left now is 2x squared, and 1x, and minus 3. So basically, I have shown that one of my factors right now is x plus 5, and one of my zeros is negative 5. We've proven that. So what we've really done, though, is we have x plus 5, and what I have left is this part, 2x squared plus x minus 3. So best case scenario is I can factor that. I can do it and break it down. If I can't factor it, I might have to use my quadratic formula over here, but this one does factor. Get 2x and x. You put your 3 here and your 1 there. It's going to be 2x and 3x. Make your 3x positive and this negative, and that works out to 1. And you got your x plus 5. So there's all your factors. And then my zeros would be negative 3/2 and positive 1. Okay. So the synthetic division is getting our problems smaller so that we can use other skills that we already know. All right, this time I have x to the 4th, so that means I need 4 zeros down here. So when I do this problem, I've given you 2 answers already. So if you looked on the graph, this graph would cross the x-axis at negative 4 and 2, like those would be x-intercepts on the picture. And so later we'll talk about that next class. So -4, let's do that one. Now 1, 3, -9, -14, and 24. Okay, so we'll get -4, -1, -5, and 20. That's back down to 6, and then -24. So that worked. All right, so now if you know more than one answer, you just keep going. You use this to keep going, and you put a 2. So you kind of stack it. You stack the 2 underneath, and then you do that one. So I got 1, you get 2, adds up to 1, get 2, makes -3, and makes -6, and we're good. Okay, so it worked. So my zeros I've proven are -4 and 2. But the problem is I need 2 more. All right, and look what I have left. I had x to the 4th, I took 2 out, so that's x squared and x. So what I have left is x squared plus x minus 3. Now, if I try to factor it like I did up here, it doesn't factor. Nothing that multiplies to 3, like if I do 3 and 1, it doesn't make 1 in the middle, so it can't factor. So I'm going to have to use my quadratic formula. That's another way I can solve quadratics. So I got a is 1, b is 1, and c is -3. So I have x equals -b, so -1, plus or minus, let's do the discriminant later. Bottom is 2 times 1 is 2. So my discriminant, my b squared. So in my calculator, I put 1 squared, right, minus 4 times a is 1, and c is -3. So when you do that, you get 1, 2 negatives makes a positive, and then this is 12. So you get 13 inside here. So that's why we couldn't factor it, because that square root is not a perfect square there. So those are my 2 answers. I have -1 plus or minus radical 13 over 2. And if I needed to, I could put those in my calculators to get the decimals, but I'll just leave it like that because square root of 13 is a decimal. All right, so last 2 problems. So again, I'm going to use the fact that these 2 are zeros and see what I can do. So -3, I got 2, 5, 13, 40, and -24. So this is working out. And I got 1/2, so it's weird to have a fraction, but whatever. 1/2 of 2 is 1, I get a 0. I get a 0, 16, 1/2 of 16 is 8, and 0. All right, so good. So what I have left right now, I have proven that -3 and 1/2 are zeros, so that means that x plus 3, and remember this one would be 2x minus 1, those are zeros. So I need 2 more because there's 4 altogether. So we're left with this problem. This was x to the 4th, so this must be x squared, x, and that. So we're basically left with this, 2x squared plus 16 equals 0. Like I have to solve that problem. So I notice that they both divide by 2. So if I pull out a 2, I have x squared plus 8. I can't factor that. 8's not a perfect square. So I think instead of doing the quadratic formula, which I could, I'd rather just do like we did earlier in the year, and let's take away 16. 2x squared equals -16. Divide by 2. So I'm left with x squared equals -8. And then I'll take the square root of both sides. Now it's a negative, so it's going to be imaginary. Plus or minus. And 8 is 4 times 2. So the 4 comes out, becomes a 2 within my I, and then the radical 2 stays in. So there's my last 2 answers. Plus or minus 2i radical 2. So if you graphed this problem, you wouldn't see those answers because they're imaginary. So the only place you would see the graph crossing would be at 1/2 and like at -3. And you might see 3 turns in the graph, but you basically only see these x-intercepts. But you know you want 4 answers, so you can't see the other 2 because they're imaginary. So your factors, one of them would be for the plus 2i, it would be a minus 2i radical 2. And the other one for the minus would be plus 2i radical 2. So it's kind of ugly, but that's just what it is. All right, this last question, is x minus 5 a factor? So basically, we just want to know if this divides into here perfectly with a remainder of 0. So we put a 5 in our box, 2, -15, 23, 15, and -25. So let's see, this is just a synthetic division question. It's just a yes or no question. Get 10. -25, -2, -10 is 5, and get -25. So my answer to this would be yes. Okay. All right, that is it. So your job is to do the questions, the rest of the questions on here. Bye-bye.